An unusual galaxy has been identified, unlike anything ever observed before. This mysterious dark galaxy emits no visible light and consists primarily of dark matter, with only a small portion being made up of stars. Its discovery raises several questions, including how astronomers even managed to detect it in the first place, and how they determined its distance from us. Moreover, this dark galaxy could provide the solution to one of the most significant astronomical puzzles, the missing satellite problem. But what exactly is the missing satellite problem, and why has it left scientists scratching their heads for so long? For astronomers, the missing satellite problem is a huge mystery in the study of galaxies beyond our own Milky Way. Dwarf galaxies, which are small galaxies that contain up to 1 billion stars, are expected to exist in large numbers throughout the universe, according to current models of cosmology. These dwarf galaxies orbit larger galaxies like natural satellites, and are thought to be influenced by their gravity. However, the number of observed dwarf galaxies is much lower than what is predicted by these models. This discrepancy is known as the missing satellite problem, and it has puzzled astronomers for decades. Although many dwarf galaxies have been discovered over the years, including the large and small Magellanic Clouds that orbit the Milky Way, a peculiar class of dwarf galaxies known as the ultra-faint dwarf galaxies, or UFDs, have proven especially elusive. Despite efforts to find them, these ultra-faint galaxies have remained difficult to detect. Recent research suggests that dark galaxies, which are made up of mostly dark matter and contain few or no stars, may hold the key to solving the missing satellite problem. While typical galaxies are composed of gas, dust, star clusters, dark matter halos, and a supermassive black hole at the center, dark galaxies are almost entirely made up of dark matter. These enigmatic objects have so far failed to ignite star formation, and these galaxies are thought to have formed just a few 100 million years after the Big Bang. Until recently, dark galaxies were merely theoretical, but astronomers have now identified the first known example of such a galaxy in the universe. It's named as FAST J139+4He28. One might wonder, how did astronomers manage to identify a dark galaxy, given that these objects do not emit visible light? Well, astronomers have employed the hydrogen spectrum as a means to detect and study dark galaxies. It involves measuring the amount of neutral hydrogen gas present in a particular region of space. Neutral hydrogen gas is composed of hydrogen atoms that have not been ionized. When neutral hydrogen gas is present in a region of space, it emits a distinctive wavelength of light, known as the 21-centimeter line. The 21-centimeter line emission from neutral hydrogen gas is a result of the interaction between the hydrogen atom's electron and proton. The electron is in a state of spin that can be either parallel or anti-parallel to the proton's spin. When the spins are anti-parallel, the hydrogen atom's energy level is slightly higher than when the spins are parallel. This energy difference corresponds to a wavelength of 21 centimeters. Astronomers use radio telescopes to measure the intensity of the 21-centimeter line emission in a particular region of space. By analyzing the emission spectrum, astronomers can determine the velocity of the gas, and hence the motion of the dark galaxy. Now, we need to answer the question that, how is it determined by astronomers that it was a galaxy? When astronomers detect an object that they suspect might be a dark galaxy, they conduct further observations and analyses to confirm its identity. One of the methods they use is to search for evidence of stars in the object using telescopes that detect ultraviolet or infrared radiation. If there are no stars detected in the object, it could be a sign that it is a dark galaxy. However, the absence of stars does not necessarily mean that the object is a dark galaxy, as it could also be a globular cluster, a diffuse cloud of gas, or an irregularly shaped dwarf galaxy. Another method that astronomers use to confirm the presence of a dark galaxy is to analyze the motion of the gas detected using the hydrogen spectrum. If the gas is moving in a coherent and organized manner, it could be a sign of a dark galaxy. This is because the motion of the gas in a dark galaxy would be influenced by the gravitational force of the dark matter, which is believed to make up most of the mass of the galaxy. The gas would therefore move in a similar way to the dark matter, creating a distinct pattern in its motion that can be detected and analyzed. The team's analysis revealed that the galaxy has a limit of 690,000 solar masses of stars and contains 83 million solar masses of HI, making its total baryonic mass approximately 110 million solar masses. However, this baryonic mass is a mere fraction of the galaxy's total mass. Through the determination of the galaxy's rotation speed, the team estimated its total mass to be 5.1 billion solar masses, indicating that dark matter makes up roughly 98% of the galaxy's mass. The discovery of dark galaxies is significant because it provides an opportunity to better understand the evolution of galaxies in the universe. By studying these objects, astronomers can gain insights into how galaxies form and evolve over time. Additionally, the discovery of dark galaxies may help answer questions about the scarcity of ultra-faint dwarf galaxies, which are believed to be the building blocks of larger galaxies. Understanding why these objects are so rare could provide crucial clues about the formation and evolution of galaxies. If you found this video helpful, please subscribe to my channel. It would mean a lot and help me create more useful content for you. Thanks for watching.